Next session will be chaired and co-chaired by Dr. Rajkumar and Dr. J.V. Thomas from Indian Space Research Organization. So I'll just request Dr. Rajkumar and Dr. J.V. Thomas, please, to start the session.
Good morning and welcome to all. After Director SAC has formally welcomed you all, and again, okay. And hello. And further, I am not spending time on this thing because we have to complete the program in time. So now, currently, I request Mehul Pandya to give the keynote address on behalf of Director SAC.
Thank you, Dr. Thomas, and good morning to all of you. It is my honor to present to you, it's not a keynote address, but on the behalf of Director SAC, overview of scientific and technological activities being carried out at Space Applications Center. So as Director mentioned, we welcome you all the delegates on behalf of, Director SAC, Deputy Director SAC, and on these Ahmedabad, which is the first UNESCO's World Heritage City of India, on these auspicious 9-day celebrations. So I'll just take you to, as Dr. Nilesh Desai ji mentioned, that Indian space program started by Dr. Sarabhai in this very city from 1940s, from his own very big bungalow to the one of the colleges here, then establishment of Physical Research Laboratory PRL, and some of the activities in SAC in 1960s. And Dr. Sarabhai, who is the pioneer of Indian space program, actually started all the activities space activities at this place. So after 1960s, Indian Space Research Organization in 1969 was formally established, and presently this is the structure of overall Department of Space, which is directly monitored, or they are reporting to Prime Minister Office. And we have got in Indian Space Research Organization major 10 to 12 major centers, and you could see various centers on the right hand side, starting from very north in IIRS Dehradun to south Trivandrum. Various institutes, various centers, they work around for all the space programs, building the payloads, building the satellites, building the launch vehicles, and launching it from Sriharikota, the spaceport of India. And Space Application Center is one of the premier centers of ISRO. Actually, research and activities at this center started in 1960s, and this beautiful center was formally established in 1972. And right now we have almost 5 major campuses. You could see the beautiful landscape of our main campus on the left top side, and we have 3 major campuses at Bhopal area. One of the centers is also situated in New Delhi, that is Delhi Earth Station, and we have got very good space exhibition center. And recently, the National Authorization and Promotional Board, Indian in Space, which is also headquartered at Ahmedabad. So this is by and large the overall centers which are there in and around Space Application Center, SAC. Basically, SAC is a unique centers of ISRO where we design, develop various navigation and communication payloads, remote sensing payloads, and all the major applications or exploration studies are basically developed and demonstrated at SAC. So it's a very unique combination of engineering and scientific talent sitting at the same place where we build all the scientific instruments either for Earth observation, planetary exploration, or space science activities. And after developing these payloads, we also work on all the applications and scientific exploration, studies. As I mentioned, SAC has basically two major components: development of scientific payloads and demonstration of their applications. Either it is for communication or navigation, or for remote sensing. It is, if it is, optical remote, I do not know why this is not focused, but anyway, I'll try to, yeah. Online it is fine, okay, no problem. So electro-optical payload development or microwave payload development, that is the major activities other than all transponders and navigation instrumentation. And once we develop these payload, we develop all the applications related to these activities. And we have partnership with the all Indian industries, academia, research institute, and many international cooperation under these, activities. And if you see the capability over a period of time, as far as Earth observation activities are concerned, we have achieved starting from 4 kilometer spatial resolution from geostationary platform to the sub-meter. That means we have achieved from 4 kilometer spatial resolution to 0.3 meter spatial resolution. All those electro-optical payloads, either it is for land, ocean, atmospheric applications, or for very high spatial resolution applications. So we have, our laboratories have developed these kind of imaging capabilities over a period of more than 4 decades and developing more than 50 payloads, and which has got, varying, as I mentioned, spatial resolution from kilometer scale to sub-meter spatial resolution. And these evaluation of electro-optical payloads have actually demonstrated unique applications, either it is for oceanography, land, ocean, land atmospheric applications, cartography, or some of the planetary exploration activities, either through Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, or Mars orbiter mission applications, or unique systems of meteorological payloads from the INSAT platform. And all those payloads, starting from panchromatic to multispectral to thermal imaging and micro imaging, have been developed over a period of more than 4 decades. And just to show, using meteorological payload of kilometer scale, where we get all satellite data sets at 15 meters, diurnal duration, to very high spatial resolution imaging of sub-meter spatial resolution. And these are some of the recent EO sensors development which we are proud of. Either it is from technology development, satellite and payloads which have got very unique capability working in visible, thermal, and some of the shortwave infrared and middle infrared observations. And right hand side panel, which you can probably can't make out some of the names, all I think 4 to 5 major systems. Overall, we contributed 11 system or subsystem in Chandrayaan 3 recent, our successful soft landing on the Chandrayaan on the moon surface. These are some of the cameras and systems which were developed for Chandrayaan 3 as well, which are these are electro-optical sensors in recent development. Other than optical infrared observations, the unique capability at SAC of building radars, starting from 70s, late 70s to recent times, our laboratory have developed radar and microwave capability. Either it is in a form of radiometers to the reset kind of recent system, reset 1, reset 1A, and it has got a very Chandrayaan 2 dual frequency SAR as well. And in future, we are going to get NASA ISRO synthetic aperture radar mission also. That has also been developed at Space Application Center. It is a unique capability of developing these radars, and you could see some of the photographs here of recent RISAT-1, which was C-band active phased array SAR system, and which gives you beautiful photographs of different hybrid and full polarimetric observations, which have been used for various applications. So this is also, I do not know why this, okay. Maritime, I said to be constellation for maritime mode also, which with the use of 3 agile systems, we could easily cover some of the important observation for maritime observations. And recent development as far as I said, RISAT 1A, 2B, scatterometer working in Ku band, and some of the millimeter wave humidity sounder, and as I said, the S band of NISAR in this NASA ISRO synthetic aperture radar mission. Other than spaceborne sensors, there are airborne systems as well, where we have been developing C-band, mini SAR, X-band, and L and S band observation with very good high spatial resolution of meter or sub-meter observation. And some of the examples you could see, I do not, this screen is not that great, but some of very unique observation in these systems, they give us the, it gives us the test bed before launching it in the spaceborne system. These airborne SAR systems are being basically developed and demonstrated for airborne experiments. And as far as applications of these systems, they go into the actual real world. What the philosophy of our applications is, we understand the user requirements. We define various sensor systems for meeting those requirements, and then develop retrieval algorithms. We develop, various products, and then using these geophysical products, we demonstrate new applications. So, and these new applications again gives, direct input to user requirements. So all these newer system definitions to user requirements, the full circle, we try to take care with the core competence on various, sensor definition to development of geophysical parameter retrieval, CalWell activities, modeling and data assimilation techniques, and giving for all these products for societal benefits and hosting on some of the geo portals also. So, as far as Earth observation, I'm not going into detail. Earth observation applications are concerned, starting from agricultural, forestry applications to cryosphere, geosphere, ocean, atmosphere, and urban regional applications to hydrological applications. So we have a strong applications group which is actually involved in these applications, and we have also very strong data analytics group which is involved in data products and data processing, development of newer techniques as well, which are basically a very strong group of computer science background engineers as well. And now using data available from various system, analysis ready data or AI ready data are being also generated using all the missions of ISRO. And these are two major web-based application, MOSDEC and VEDAS, either for terrestrial application or for atmosphere and ocean application. So various kind of data sets, products, and near real-time monitoring and observations are available on these two applications portal of SAC. Now, after looking at Earth observation capability, I will just take you to very quickly, the satellite communication program, which started in early 80s, and now it has reached to a very maturity level. All the transponders for Indian needs are catered through the various kind of transponders and communication systems being developed at SAC. And using very high throughput satellites, mobile satellite services are being developed. This is one of the examples, which is the one of the highest or one of the heaviest satellite communication payload on board GSAT-11, which is giving the high throughput output for communication link. And one of the important points to mention is we also developed the South Asia satellite, which was the gift to South Asia region by our Honorable Prime Minister, and which has got a dedicated networks for hosting services by member countries. So other than, it had 12 Ku band transponders, and mission life is of 12 years, which is a great gesture from Indian Space Research Organization to the our South Asian region. And these are some of the some of the newer SATCOM and SAT navigation payload recent development. Either it is in terms of GSAT-24 payload or NVS, that is IRNSS 1J payload, or beautiful payload named Spectrum Monitoring Payload SSLV for on the some of the developmental flights. So this also recent development as far as SATCOM and SATNO systems are concerned, and these kind of systems are also useful in disaster monitoring and support to some of the very extreme events across India. This is one of the examples of flood which occurred in Jammu and Kashmir, where these communication systems are being installed and used for rescuing various human and assets. And the navigation system, which is Indian Constellation Navic system, which was named by PM as a NAVIC, which is IRNSS system, which was named NAVIC by Honorable Prime Minister, which has got in a single frequency mode the resolution or the accuracy somewhere around and less than 10 meter, and in a restricted positioning and strategic application, it gives less than 5 meter using dual frequency mode. The accuracy is within 5 meters. So this is also being now integrated in iPhone 15 onwards system. And I do not know why these these were some of the videos which we tried to show as using the Navcom. Just 5 minutes, sir. I'll complete within 5 minutes. This Navcom application, which have been used uniquely to monitor the near real time of all the express train of India using our navigation communication services, either or it is for fishermen. They are roaming around in international borders, or real-time aircraft tracking system as well. So these were beautiful videos, which I do not know why it is not showing in these thing, but it's okay. So navigation, communication for better governance is also being actually developed and demonstrated. Other than all these, activities, SAC is involved in one of the state-of-the-art kind of activities, critical and advanced technology initiative, either developing the atomic clock or Ku band TWTA, high 200-watt TWTA, or some of the right-hand side top is very important, contributed to quantum frontiers. Using free space, there was a breakthrough, demonstration of free space quantum key distribution. That experiment was also carried out at SAC, where, this testing of quantum communication key was also demonstrated. So this was a 300-meter free space experiment, which was carried out between two adjacent, 300-meter far away building in 2024, which was the first of its kind breakthrough demonstration of quantum key distribution experiment. And just one or two last slide, as I mentioned that this is going to be a game changer technology. NASA ISRO SAR observatory where S-band SAR was developed at SAC and which has been now, which is being integrated and it is being readied for its, launch from Sriharikota, and which will be very much useful for ecosystem applications across world. And this is going to be very important contribution from ISRO. And just before I complete, some of the advanced R&D, which also includes development of sub-millimeter wave terahertz technology, where antenna development, antenna to multi-tier cryogenic cooling system to some of the detector systems, which are very important for observing the deep cold old space, which will be useful for some of the probing the space. And this is going to be first of its kind terahertz telescope in the north of the India at Hanle, very dry place, and which will be useful for some of the space exploration activities. So this also being developed at SAC, and some of the activities related to Indian human space flight program, the cabin sensors and various subsystems are also developed at SAC. And these are some of the glimpse of SAC main campus fabrication, testing and quality control laboratories. These are some of the bigger technical infrastructure at SAC new campus. One of the major feature is capacity to integrate 6 big payloads in a one single clean room, which is one of the biggest clean room of this part of Asia. So these are unique facilities of SAC, and we also conduct various training program through UN and other banners. We have very vibrant outreach program, and we have got very beautiful space exhibition also just in front of our campus. If time is there, you must visit that particular space exhibition. And I will just stop here with this important and beautiful image of Chandrayaan-3, majestically Chandrayaan-3 soft landing, which was a historic soft landing at near South Pole, and where you could see in our OHRC image Chandrayaan-3, which is there, lander, which is being basically captured through rover. So I thank you for your patience hearing, and I thank you for giving me the opportunity. It's been honor on behalf of SAC and Director SAC. Thank you.